of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to kindly request our members to subscribe and engage us in the comment section, and also ring that notification bell so that you can be getting various updates on the uploads that we do on similar topics. So today we're going to look at differentiation of our trigonometric functions, and basically we're going to look at this particular function of the tangent given as this. So we had said that basically we have got three basic trigonometric ratios, and also there are reciprocals which of course constitute the sec, cosec, and the cot of a function in that specific order. So we're going to do a series of short videos on these specific functions, and basically on the concept of trigonometric we're going to employ some aspects of the previous discussions that we have had on the chain rule, the product rule, the quotient rule, and perhaps some of the aspects that we have discussed on the various rules of differentiation. And of course they're going to assist us in finding the values of this specific differentiation of trigonometric functions. So we had given from our previous discussion the implication of the concept of the tan of a function, and we said that the tan over x basically is the ratio between the sine of a function and the cosine of that specific function given as such. And in us trying to find the differentiation or the differentiation of this, in us trying to evaluate the differentiation of this specific function, we're going to employ one of the basic rules that are mentioned, of course, or just mentioned in this specific case. So I'm just going to reduce this space so that we can have a large area for us to bring this particular evaluation. So I've said that the tangent over x is equivalent to the sine over x over the cosine of x. And in this case, for us to find the d over dx of the tangent of x, we're going to employ this specific or substitute it with this specific of course ratio which I've given for the sine and the cosine over x. And of course this is going to be achieved using one of the rules we have studied on the quotient rule under differentiation. And we said that for the quotient rule, if we have a function f over g, or two functions given as f over g, we are going to find the derivative over that specific function given as g x f prime of x given as such. And then we're going to have this one given as fx g prime over x given as such. So basically the numerator of this specific differentiated or the derived function is going to be appearing in terms of the difference between this first derivative of f times the other function gx minus the function fx as a together with the product of the first derivative of the second function g given as such. And then we're going to have that one given all over the square of this specific function we have for g x given as such. So we're going to employ this specific aspect having talked about this particular set of a function appearing in terms of a quotient, and therefore that is going to assist us to find the derivative. So so this one is going to be given in terms of d over dx is equivalent to the sine over x over the cosine over x. So for us to evaluate this, we're going to consider this sine over x represented by the function over f, and then we're going to consider the cosine of x represented by the function g given as such. So therefore we're going to apply the quotient rule. So the gx for us is going to imply the cosine over x, and fx is going to imply the sine of x in that specific order. Therefore implying that d over dx, the sine over x, so this basically is the sine of x over the cosine over x, is going to be given or can be given in terms of gx. So our gx is represented by the cosine over x, and then we are going to find this one with the product of the first derivative of fx x. Our fx in this particular case is the sine over x. Now the first derivative of the sine over x is represented as the cosine of x, implying that the d over dx over the sine of x is the cosine of x given as such, and that is going to give us gx and f prime of this specific. And then we're going to minus the fx in this particular case is represent the sine over x. So that one has been held constant, and we're going to give it from the, of course, quotient rule in that specific order. And then we're going to have the g prime over x, and we said gx is represented by the cosine over x, and that one is going to be given in terms of the negative sine over x. So implying that the derivative of the cosine of x is the negative sine of x given as such. And then we're going to have this one divided by the square of gx. So we have said that gx is represented by the cosine over x. So therefore the numerator for this one is going to appear as the square of the cosine of x given as such. So in trying to evaluate this one, we have talked about the concept of course, what we refer to as identity. Now the product of the cosine over x plus the sine over x due to these two specific signs for the positive is going to give us unity. So we're going to have the square of the cosine of x plus the square of the sine of x all over the cosine of the square of the cosine of x is equivalent to unity, which is going to be represented as 1 over the square of the cosine of x given as such. Now from the specific ratios we are given for the three inverses of a trigonometric function, this is going to be given in terms of the sec. The sec is the inverse of the cosine. So basically that implies that this particular answer is the square of the sec of x given as such. So implying that the derivative of the tangent over x is equivalent to the square of the sec over x, given us from this specific evaluation that I've done on the board. So basically this is how we're going to handle the derivative of the tangent of a function. And of course, as we're going to go ahead, we're going to do various evaluations and try to confirm whether basically this particular rule that we have come up with is applicable. So that is it for now, guys. I hope that we have seen how we can come up with that specific product using this particular evaluation that I've done, using the concept of identity and the quotient rule in that specific order. So that is it for now, guys. Bye, God bless you. Catch us in our next video.